Okay, now check the input voltage, AC voltage here, 250 voltage. Also now check the bridge input. Here is also 200, yes, 250 voltage. So this is bridge rectifiers. So until bridge rectifiers, we adjust your multimeter in AC mode and we check AC voltages. After a bridge rectifiers, we check DC voltage and multimeter will be adjust in DC voltage. So now check the output voltage of bridge rectifier. Yes, here we get 307 voltages. Also in the main filter capacitor, here is also 307 voltages. In standby mode status, we get this voltage in these pointers. So this is a minus sign, so this is common ground for these sections. So we can use the ground to measure and check pointers. So we can use this one. This is connected to this one. So this is the ground pointers. So I will keep my ground pointers in this one and I will check any voltages in these sections. So here is 307 voltages. 307. So here is a resistor, series connector, surface mounted resistors. So this surface mounted resistor drop the voltages. So here is some voltage drop also here. Finally we get these voltages here, 1.9. This voltage supply for the PFCIC line voltage pin number 1. Yes, here is 1.99 voltage. So first time this PFCIC will give this voltage, no need another voltages because our television is standby mode. Any other checking point is this one. This is surface mounted diode. So here is the input AC voltage. So the output of this diode is DC. So we measure DC voltage. Here is 200 voltages. Sometimes we get 198 voltage. So this line we get 200 voltages. These lines. Here is also 200 voltages. Line voltage pin number 80. We get 200 voltages from 194 to 200 voltages. We get in these pointers. So the other point is here. Pin number 1. Pin number 1. We get 2.3 or 2.4 voltages. Now this IC will conduct the frequency for the switching transistors in pin number 16. Pin number 16 is connected this one. We get from 110 up to 140 voltages here. So this voltage switch or on off by the lights of this transistor and will conduct for the secondary sides of this power supply. So this is a transformer. So this transformer transfer for the secondary side and we get the voltage here 7.84. At the same time, in the primary sides of this transformer, here is the in the primary here is another coil. This coil will transfer the frequency for these pointers from this one to this. There is a diode, rectifier diode. That rectifier diode make a VCC voltage for number 2. I will show this one. Yes, here, yeah, 13.2 voltage. This one transfer to this point and will be in number 2. Yes. So now multi-IC will be with the power on signal from the remote control. Turn on the television from these buttons. and power on signal will be sent from the RPCP to the mainboard, from the mainboard to the power boards. So in the power board we get the power on pointers. Look, this one here, this main plate indicated this one, these pins, and this main plate implies these pointers, these connecting pointers. So here a text or a main plate power on. This is to show these points, these pins. So this pin is a power on pin. So when you press power on the remote, we get power on signal these pointers. So now check these voltages. Power on signal. The power on signal will be 3.3 voltage. So this 3.3 voltage will transfer to the primary sides of the power supply. So follow these lines and we get this resistor. Yes, 3.3. After this resistor we get these transistors. This one is connected with the optocoupler. Optocoupler transfer the power on signal from this secondary side to primary sides. So when we measure this side voltage, we keep the multimeter ground here and check the voltage. Yes, so this voltage will be the surface mounted transistor here, and this surface mounted transistor connected with generator, that is series transistor regulator, and will make constant voltage for the PFC and feedback for multi-IC. The voltage outputs for PFC. Here we have a diode. After the diode, we'll get this voltage. Follow these lines, and will be this line to this resistor. Yes, and we get PFC pin number 8. Also, this voltage will be transferred to this multi-IC pin number 9. So now check this one. So passing to this one, this diode. Yes, after this diode will be a resistor here. Yes, after a resistor we get 8.8, almost 9 voltage, pin number 9. So now the PFC and the multi-IC working fully. So now in the mean filter capacitor we get this voltage, 400 voltage. Yeah, 386 voltages. In the multi-IC output, HVG voltage will be high. Yeah, 204 or 201, from 200 to 204 voltages. LVG voltage, 4 voltages. Yes, 4 voltages. In standby mode status, this point is 0 volts, no output voltage by these directions. In this way, we get 111 out of 140 in standby mode status, but now we get 200 voltages. So this multi-switching transistor now develop high frequency for the chopper transformer. Now the chopper transformer will be transferred from the primary side to the secondary side. So in the secondary side now we get 13.2 voltage here. Yeah, 30 voltages. In standby mode, in this testing point we get what? 7.8 voltages. But now this board working fully, 100% working, and we get these voltages. So this voltage is multi-voltage in this model televisions, but in other model televisions we don't get these voltages. So this voltage also for the main boards and for the backlight drive IC. This is the voltage pin number 2. Yes. So now the backlight drive IC will start working, and of the voltage to pin number 4. This pin number 4 will be activate these transistors, these regulator transistors. Yes. After this transistor, we get these voltages, regulator transistor here. We get this voltage directly connected to the minus side of the backlight. The positive side of the backlight will be out by these diodes from these pointers and will be reached here, the positive side. When we measure the voltage here in the backlight, we get this voltage 150 voltages. In standby mode status, in this point we get 40 voltages.